Hello, and welcome to Group 66 Software Architecture and Design Group Project Presentation. We're going to start by double-clicking the osmosis.jar file located in the desktop. Once opened, let's first explore the different sections. The section named Lawn is where the grid and the simulations objects will be shown. This section allows us to visually inspect the state of the simulation. On the top right-hand corner, we find the simulation summary. This section displays important statistics such as the turn counter, the total number of grass squares in the simulation, the number of grass squares that have been cut by the lawnmowers, the remaining grass squares to cut, and the next object to take an action. Right below, we find the mower status panel. This section displays the individual statuses for all the lawnmowers in the simulation. The output panel shows a log of all the actions that have been taken by all the objects in the simulation. The Expert Output button allows the user to save the report file into a desired location within the file system. Finally, the Commands panel contains 4 buttons: Load File, Next, Fast Forward, and Stop. The Load File button allows the user to load a new simulation scenario as described by a plain text file. The Next button allows the user to step through each action in the simulation. Fast Forward button automatically plays the simulation from the current step all the way to the end without any user intervention. Finally, the Stop button stops the simulation. Let's load a file. Click on the Scenarios directory, and let's select the scenario.txt file. You will notice the scenario loaded in the application. This lawn is size 10 by 8 with 3 lawnmowers, 5 craters, and 2 puppies. We're going to step through the simulation first to see how the application works. If we click on Next, we see the mower number 1 has decided to scan, and it discovered this particular grass and crater squares in its surroundings. The next object will be lawnmower number 2. It also decided to scan and discovered these squares in its adjacent surroundings. Finally, lawnmower number 3 decided to scan as well and discovered these squares in its surroundings. Puppy number 1 has decided to stay. Puppy number 2 has decided to stay as well. The way the puppies move is by taking a probability function into account. This has completed 1 turn in the simulation, and you will notice the turn counter has increased by a number of 1. Now, mower number 1 has decided to position itself looking northeast. Mower number 2 has decided to move 1 step north. Mower number 3 has decided to move 1 step westward. Puppy number 1 has decided to move to square in coordinates 1, 7. Puppy number 2 has decided to stay. We're going to step through until we find one of the interesting states of the simulation, and that is when a puppy steps on top of a lawnmower. Once we encounter this case, the affected lawnmower will be stalled by the puppy until the latter decides to move away from the current square. In this case, lawnmower number 2 is set to stalled. Now the puppy moved and the lawnmower's status is set back to on. Let's fast forward until the application stops. Notice that there's no user intervention involved. The simulation has ended, and now we can click on the Export Output button to create the report into the desired location within the file system. Let's give it a name. In this case, it's set to report.txt by default. Go into the desktop and opening the report.txt file will display all the actions that have been taken by all the objects in the simulation. Let's go back to our simulation and consider an error case. What happens if the file that we try to load contains errors? For example, we have this particular error in one of the scenarios. This is a bad scenario because it does not follow the format required by the simulation. Let's attempt to load it. The file fails to load and the application gracefully displays the error. We can again load a valid scenario and the simulation will restart from the beginning. On the technical side, this application was developed using Java both for the backend and the front end. The lawnmowers used a backtracking algorithm to find their way around the lawn and to find the grass squares to cut. The puppies used a probability function to decide whether to stay or move. Thank you for watching, and we hope you enjoyed.